Hello guys, how's it going? This is a Corda technical demo of state pointers and bulk querying behavior. There's a very large audience here today, which is great, and I look forward to talking about these new features that have been added in Corda 4. We'll start with state pointers to begin with. Now, the interesting thing about this feature is that it doesn't actually enable something in Corda that wasn't possible before, and I'll explain why. But in a nutshell, what do state pointers do? Well, sometimes there's a need to reference one contract state from another, and as it says on the slide, this has got the effect of creating a unidirectional one-to-one relationship between a pair of contract states. So that's pretty much what it does. So inside your contract state class, you have a property that is of type, say, state ref or linear ID, and then that creates a link to another contract state. So it's very, very simple stuff. But you could do this before in Corda 3, and indeed I've seen quite a few developers do this in their Corda apps. But the pattern wasn't formalized in Corda 3. So what I've done is formalize this pattern by adding the state pointer types. And I'll just go through how it works very quickly. This shouldn't take very long, actually. So you can link by state ref or linear ID, as I alluded to before. So if you link by state ref, we use this thing called static pointer because the reference is static. It doesn't move. The state ref is a coordinate, if you will, for a state on the ledger. It's a transaction hash and an integer, with the integer representing the output index of that output in a transaction. So you would use a static pointer if you want to refer to a specific version of a state in a lineage of states. So if that state is updated, well, then it doesn't matter. The static pointer will still point to that specific state ref. So you can see in the code example at the bottom, I define a bar state, and it's got a string, some data which is a string in it, and you can see it's a contract state. And then we also define a foo state, which has got a ref property, which is of type static pointer that takes a type variable of the type of the state that you're referring to, which in this case is the bar state. So that's it. It's pretty easy. That's all there is to it. If you want to link by linear ID, then you probably want to do this because you always want to link to the most recent version of the state, right? So you know already probably that when you query the vault by linear ID, if you've got the vault by default only returns unconsumed states. So that vault query for a specific linear ID will return the most up-to-date version of that linear state, right? So of the lineage of state transitions of that linear state, you will get the most recent version. And that's exactly how the linear pointer works. So to create a link to the most up-to-date version of a state, use a linear pointer. Obviously, you can only do this with linear states. You can't do it if there's no linear ID or no common ID for each version of the state. So you can only do this with linear states, and you use the linear pointer type instead of the static pointer. And again, there's a type variable, which is the state that you're pointing to. And it's actually pretty simple. There's not really much else to note. Where it gets interesting is using pointers and resolving pointers, and I'll go into a bit of detail around what that is, and then I'll get to go into a bit of detail around what happens if you haven't got a state that a pointer points to, and what the behavior of Corda would be in that case. So how do you use a pointer? It's actually pretty easy. We've got the bar state and the foo state again. The foo state has a static pointer to the bar state. Let's just assume that these states, the bar state has been committed to the ledger. Then what I can do on line 6 is I can then query for that bar state. That's just a standard bulk query that gives me, it will give me the single bar state because I've only created one of them on the ledger. Then what I can do is I can create a pointer to the bar state. So I create a static pointer that takes two properties. One of them is the state ref of the bar state, and the other one is the Java class for the bar state. It takes the class because when we deserialize the pointer, we want to know what type it points to. So that's pretty important. Then next, we create a foo state, and we put the pointer to the bar in it. And now we got our foo state, so we can add it to a transaction. There's actually a typo on this. This foo state, the parameter for foo state should actually just be the parameter for output state should just be foo state. Whoops, that's a mistake, but I think it's pretty obvious that I create the foo state here, and I could just add it as an output here. Now, the really interesting thing with the transaction builder in Corda 4 is that when you add a state object that contains a state pointer, it automatically adds the pointed to state as a reference state. Okay? So that's really important to remember. It automatically adds the pointed to state as a reference state. So we did a talk yesterday on reference states. So if you don't know what a reference state is, then please look up that talk, and you can find out all about what reference states are. In short, reference states usually contain reference data which can be reused in transactions. So a state, if it's in the references list, doesn't get consumed when the transaction is committed to the ledger. The notary checks that the reference state is the most current version, but it doesn't add the state ref to the spent list in the notary's database when the transaction is committed. So that's just a quick primer on reference states. But for now, let's concentrate on the transaction builder. So just to reiterate again, when you add a state that has a state pointer in it, the pointed to state will get automatically added as a reference state. Now, what actually happens is that when you store that transaction in your vault, let's say this is done in a flow, and then we do a finality flow, and we commit it to the ledger, this transaction will get recorded in the transaction store, and the vault will be notified that there's potentially some output states to store and some input states to consume. And what happens is, if there are any relevant inputs or outputs in a transaction, then any reference states in that transaction will automatically get added to the vault. So I think I covered this yesterday in the talk about reference states, but it's important to note here. So basically, if you have a reference state in your transaction, and the transaction involves an output or an input that's relevant for you, you will always store that reference state. Now, this is important to note because more often than not, the reference states are not going to be relevant for you. And what I mean by that is the participant of the reference state is probably only the party that created the reference state, created the state used as a reference state, and can update that state as a reference state. It will not be relevant to you. It will only be relevant to what we call the maintainer of that reference state. So this is a different behavior to what happened in Corda 3, where typically only relevant states would be added to the vault unless you were using the observer feature. So here, this is definitely some different behavior. And I'm going to talk about the vault relevancy status, which was added in Corda 4 as well at the end of this presentation that is related to this. So how do you resolve a pointer? Well, obviously, if you've got a pointer pointing to something, then you want to be able to resolve it and look up the actual state ref or the linear ID to get the state and ref. So you can resolve state pointers inside flows or inside the verify function, and it works inside the verify function because as I said, all pointed to states are added as reference states. So you can always just look up the state inside the transaction, inside the ledger transaction. And I note here again, the reference states are not usually relevant to the node storing them. So that's pretty important. So how do we do this in code? Well, you can see this is really just a copy-paste of the code from last time. So lines 1 to 8 are the same. So I create the pointer to bar, which is a static pointer, but then on line 10, I resolve it. So I just call the resolve method on pointer to bar. I pass in a service hub instance because this is done inside a flow, and I get a state and ref back of type bar state. So that's pretty simple. Then if you wanted to do it inside a ledger transaction, then you just pass the ledger inside the verify function, you just pass the ledger transaction into the resolve method, and it will return the state and ref for the pointed to state. And that's really all there is to it. So I'll leave state pointers there. Any questions on state pointers? No? Okay, great. So Vault Query, actually one thing I'll talk about with linear pointers is that if you resolve a linear pointer, you don't actually have any guarantees that the state that is returned is the most recent version of that state in the objective ledger sense, right? Because you may not have received the most up-to-date version of it, right? So it's just the most up-to-date version that you currently have. But then it's also worth noting that if you try and resolve either a static pointer or a linear pointer, and you get an exception along the lines of cannot resolve pointer, then it means that you do not have that state in your vault, right? That shouldn't normally happen, because if you receive a state with a state pointer in it, then the pointed to state will automatically get added as a reference state to the transaction, which will then automatically get added to the vault. But there might be some very infrequent edge cases where that doesn't happen, and you would then potentially receive an exception when you try to resolve a pointer. Now, in the case where that happens, then what you need to do is ask the node which created or and updates that state which is pointed to send it to you, such that you can store it in the vault, and then you will be able to resolve it. But I think it's highly unlikely this would happen. I think if it does happen, it's probably it's probably a bug that has caused it, or some edge case that I haven't managed to uncover when building out this feature. But if you do see anyone that has problems with resolving state pointers, then do point them in my direction, because it's probably a bug that we need to fix. Yeah, sure.
So the state pointers will be. Otherwise, I'm question.
Yeah.
I can just yell at it. Yeah. So when it comes to the state pointers, will the platform stop me from using the state pointers if I run on a network where the minimum version is lower than 4?
No. Oh, yeah. Sorry. Yes, it would do. Yeah.
Okay. Because if it didn't, I can imagine then inside my verify method, I could assume I could run some verify code that's trying to get the state using a state pointer, but it would not be on the transaction because the reference state is not added.
Hang on a minute. Let me. Thanks for the question. This is a very good question, actually. This is more complicated than it seems, actually, because the state pointers feature is intertwined with the reference states feature. Now, reference states is only enabled in minimum platform version 4 or greater. Therefore, actually, you cannot use state pointers. Well, firstly, you can't use state pointers in version 3 because they didn't exist, right? But so you would need a minimum platform version 4 and running on a Corda node with version 4 or above to use this feature. If that answers your question.
Well, so I can be running a Corda 4 node that's got Corda 4 platform code.
Yeah.
But the minimum network version is only 3.
Oh yeah, then you wouldn't be able to use this. Yeah, you wouldn't be able to use this, because if you did, then when you tried to add the pointed to state as a reference state to your transaction, it would fail, right? Because reference state is only is gated for minimum platform version 4,
yeah.
Which is a interesting, I guess, side effects of the minimum platform version, because I guess the difficulty is this feature itself isn't gated with the minimum platform version, but something that it relies upon is. So yeah, that's why you see that behavior.
And Richard, I know that sounds annoying, but you have to think through what would happen if that were not the case. If you were able to create reference states and use them on a node that's a v4 node on a network that has min platform version 3. You've got to think through, well, what does min platform version 3 mean? It means it's permissible for there to be version 3 nodes on that network. And then if you were to happen to send this transaction to one of them, or if it were to be in the history of another transaction, even if it were a v3 style transaction, that node wouldn't be able to deal with it and everything would fall in a heap. It also means if it's a min platform version 3 network, such as Corda network is right now, it's likely the notary is v3. So when you try and get the transaction notarized, it won't have a clue what to do. So the min platform version there is there. I know it's annoying, but it's there to massively simplify the experience for the developers and the users. But it is annoying because you want to use a feature, you need to be on a network that mandates everybody is able to understand that feature.
Well, thank you, Richard. Okay, any more questions on this stuff? Okay, cool. Right, vault query behavior. So I actually mentioned this in the presentation yesterday about reference states, but I'm going to mention it again. So firstly, what does relevancy actually mean? Well, a state is relevant for you if a public key in the participants list, remember that participants is a list of abstract parties, which is basically just a public key, or some an X500 name as well, if it's a party, or if it's an anonymous party, then it's just a public key. If one of those keys matches with one of the keys already in the key management service, then we say that this state is relevant for you. So that's how it works, and I think this was one of, so Mike added this at the very beginning of Corda. I think it was some code originally designed for Bitcoin J, and it was kind of ported into Corda. So this is, I guess, a throwback from the Bitcoin times when Mike was working on Bitcoin J. The notion of relevancy in Corda can be a little confusing. I think every state type, apart from the ownable state, uses a check for relevancy that checks all of the participants. So if there's a key match in the participants list, then that state is relevant, and that means it will be stored in the vault, right? So imagine if you have a transaction with two outputs, one with a key in the participants list which matches one of yours in the key management service, and one which doesn't, then if you store the transaction using the only relevant flag, then only the relevant state with the public key that matches will be stored. If you store that state with the all visible flag, then both states will be stored in the vault regardless. If you store the transaction with the none flag, so store no states, then even if there's a relevant state, it will not be stored. However, you wouldn't typically do that because obviously you would want to store states that are relevant for you. Now, in Corda version 1, the concept of relevancy was quite simple. You had a whole bunch of state types, and typically it was if it was a key match in the participants list, then it was relevant. Apart from the ownable states, which is the exception here, where the vault checks to see whether the owner, the abstract party in the owner property, whether there's a key match there, and it doesn't check the participants list. So that's a bit confusing. I don't know why it's like that, but that's just the way it is. So you need to be aware of that. But in Corda 1, that's how it's worked. However, in Corda version 2, we added this feature called the observer feature. And that's where this states to record enumeration came in that I just talked about before. So you can record transactions as only relevant. You can record transactions with all visible states or none at all. When you do transaction resolution, typically you would do states to record none, because you don't want to record output states in prior transactions because they're all consumed anyway. You would only want to record the states in the head transaction. So the default behavior in Corda 1 was just to record only relevant states. And this worked because there was no way that there was no way you could get an irrelevant state in the vault. The assumption was that if you had a state in the vault, it was there because you can do something with it. So one of the keys was yours, therefore you could perform an action upon that state. However, when we added this observers feature and people started recording transactions with all visible, then there started being states stored in the vault that you couldn't actually do anything with. So let's say, for example, we store a transaction involving two cache outputs, one which is relevant, one isn't, using the all visible flag, then we would store both of those cache states in the vault. Now, if we go and ask the vault for what are our cache totals, then the non-relevant states would also be included within that cache total, thus giving us a number which is incorrect, right? So obviously that's not ideal. In Corda 2 and 3, there wasn't a capability of querying the vault with a relevancy flag. So you would always get back all states regardless of whether they were relevant for you or not, and this was not ideal. So given the fact that we added this feature in Corda 4, whereby you always store a reference state if there's in the vault if there's a state pointer in one of your states. So maybe that reference state isn't relevant for you. So you're going to be increasingly getting not relevant states in your vault. So I thought that we needed to add this flag to perhaps discriminate and say, well, I don't want not relevant states returned from the vault. So that's exactly what this relevancy status flag does. It's an enumeration with three possible values, either relevant, not relevant, or all. So the default behavior is to return all states because that's the only way to add this in a backwards compatible way. But typically, when you do a vault query, you probably want to specify the relevancy status to only relevant. And thus you can be sure that you will only get the relevant states for you. However, if you want to potentially search for a state that was used as a reference state, then you would set the flag to all or not relevant. And that's really it. I think this is a subtle but important thing to note. Because if you suddenly start getting states returned from a vault query that you don't necessarily expect, the reason why is because the default behavior is to return all states. Now, I don't think this is actually that much of a problem, really. I mean, if I think about the times when I used the vault to do vault queries, well, I would either just query by linear ID, return for a linear state, I'd query by linear ID to get the most up-to-date version of that linear state. So that will only ever return one state or nothing. And then I use the vault to do coin selection to select fungible states for spending. And the way coin selection works is it only operates upon relevant states, so it handles it for you. But I don't really think there are many other cases where I would perform a vault query and that returns irrelevant or not relevant states. I think one thing to watch is if you look at the code for cache totals or token totals in the Corda platform, I changed it so that it only performs the totals on relevant states, which makes sense, right? So if you have any similar code in your app, then you would need to make sure that if you are storing states that are not relevant, then of that state type, then say cache or token or whatever, then you need to make sure that when you're totaling, that you only do it over relevant states. I know I belabored that point a little bit there, but it's an important one to note. It might be the source of some bugs in your app if you don't quite understand how this behavior works. Yeah, sure.
Yeah, it's easy. So you said you put the cache states as an example where you want to query the cache states that you are maybe eligible to spend.
Yeah.
Now, to be choosing just relevant states, that's not necessarily the cache states that you can spend. So that's the states where you are among the participants. So even among those relevant states, there may be states that you can't spend. So my question is, why wouldn't you most of the time, rather than be querying for either relevant or not relevant or all, why wouldn't you want to pass in some custom query almost all the times? Like, let's say if I'm building a wallet and I want to get all the coins that I can spend, I don't see myself querying for relevant. I don't see myself querying for non-relevant or all. I see myself querying for states where I'm the owner. So why do we why are we building this relevant flag if I could probably use a custom query?
That is a good point. So yeah, if you've got a custom schema for your state, then yeah, you can query by owner if you want to. And that in the case that you state, then yeah, that's right. If you query by owner, and you use, say, your public key, let's say everyone uses the same public key for all transactions, then yes, by definition, you would only get relevant states returned. If you query using a public key that is not yours, then yep, you will get only not relevant states returned, right? But I think that this is more for kind of more subtle edge cases where maybe you want to do a cache total, right? And you're using confidential identities. So you've got many public keys. So it wouldn't be practical to pass in all of those public keys into the query. So you just want a nice way to say, hey, just give me all the ones that are relevant and all the ones that are not. But yeah, it's a good question. I mean, most of the time you'll probably just do a custom query and this wouldn't affect you. But I think there are some cases where it might affect you. And I think that the way it'll be manifested is that you would do a query and you would or you write a unit test and you'd expect it to return maybe one state or zero states, and it returns more. And you're like, wow, what's going on? And the answer is probably because one of the states that was stored is a not relevant state, and you're returning it in that query. Cool. Cheers, Alex. So that's it, actually, on state pointers and the Vault query behavior. I don't think there's anything else to note, and if there's no questions from the guys on the phone, then I think we can probably leave it there. Okay, thanks very much, guys. Cheers.